Hi everyone, welcome to our lesson on finite geometric series. A series is simply just a sequence where we are going to add up all of the terms of the sequence. And here is our formula for finding the sum of a series. You need to know what these pieces represent, so we're going to go over that first. So when you see this formula, you need to know that A1 represents the first term of the sequence. And then R is the common ratio of your sequence when it was in sequence form. The common ratio is the number that each term is getting multiplied by to get to the next term. Okay, and then N, the things that we're going to put in for N are going to be the number of the term that we're referring to. All right. So we're going to jump in and start practicing. Let's say that we need to find the sum of the first 5 terms of this series. You can see that it's a series because we are adding all of the terms of the sequence together. Okay, so we have to identify a few things. Based on our formula, we have to know the first term, and we can see that in the list here, a sub 1. That is 2. Okay. And we also need to know the common ratio. So we need to figure out what each term is being multiplied by to get to the next term. So from 2 to 6 and then 6 to 18 looks like they're being multiplied by 3. So that's our R. And then we're going to find the sum of the first 5 terms. So our N is going to be 5, the amount that we're referring to. Okay, so our formula was the sum equals a sub 1 in parentheses 1 minus r to the n over 1 minus r. Okay, we're going to start filling in this info that's over here to the right. So S sub n equals 2. We're going to have 1 minus our common ratio raised to the 5th power over 1 minus our common ratio again. Okay, we're going to do the order of operations inside the parentheses first. We're going to calculate this numerator and the denominator. Okay, then we can multiply by our 2 on the outside. So on the top here, we're going to end up with negative 242. And that goes over negative 2 if you're calculating along with us, which is going to be 2 times 121. So the sum that we're arriving at here is 242. So that should be the sum of the first 5 terms of the sequence. And if you want to double check and you're able to double check if it's a small amount of terms that you're needing the sum for, you can go in and do that by hand for sure and see if the numbers match up. So we could go in and figure out, continue to multiply by 3, 18 times 3, and then that number times 3, and we could add up the first 5 just to make sure that it matches. All right, now we're going to take a look at an example problem where a situation is being modeled by this formula and see if we can use that to find the answer to the question that they're asking us. Okay, so suppose that we have a ball that's dropped from a building and it's going to hit the ground and start bouncing until it comes to a rest, and we can see that we're given the sequence that models this scenario. Okay, so here's our sequence here, a geometric sequence, and we want to know what series would represent the total distance that this ball is going to travel after it completes the bounces. So what we're going to do is we're going to analyze this situation a little bit. Okay, so we can see that for each bounce, the ball is traveling 70 inches. Okay, when it bounces, the vertical distance up to the top is 70 as well as back down. So we're going to have to double this amount for each complete bounce. So we're talking 70 inches up, 70 inches back down to the ground. And then the next time that it bounces, it'll be a little less high. Okay, it'll be a little shorter. It'll be 70 times 0.8. and then back down to the ground, and then so forth. You can see that in the terms here. All right, so what would really model this sequence would be 70 times 2, which is 140 inches, and then 140 times our 0.8, and then 140 times our 0.8 squared, and then we're not sure how many bounces it's going to have before it comes to rest, but we're going to let n represent that. Okay, so here's our setup for this series. Now, let's see if we can answer a question about this. How far would the ball travel in 6 bounces? Well, we developed a series on the previous slide, so if we need to know about 6 bounces, we can take, our sequence through the value of 6, or we can use our sum formula and find that. All right, so with our sequence, our A1 was 140, okay, in our list on the previous slide. Our common ratio was 0.8. That was given to us in the problem. We would like to know about the first 6 bounces. So when we need an n, we're going to use 6. Okay? So filling in that same formula that we saw earlier, S sub n equals A sub 1. Then we're going to need 1 minus r to the n, again, over 1 minus r. So let's fill in our information. For the first 6 bounces, we need to have 140 multiplied by 1 minus 0.8 to the 6th power for the 6 bounces over 1 minus 0.8. Okay, and we're going to follow the correct order of operations here. We're going to calculate numerator inside parentheses and then denominator. We're going to get that division going, and then once we have the number inside parentheses, we're going to multiply by 140. So following that order, if you're calculating along, you should come up with 140 times roughly 3.689 in your parentheses here. I'll give you that number so you can check. And then final distance, answer of about 516.5 inches. All right, so we modeled using a geometric series. So this concludes our lesson on finite geometric series.